everybody. My name is Alex Justin. I'm the microcontainer lead, and I'm going to talk about the new class loading layer in the new JBoss 5, actually in its kernel microcontainer, and what are the current OSGI features that we have or support. Then Scott is going to help me with some of the demos that we run as part of the presentation. Like I said, I'm going to explain something about the new class loading project, being actually a sub-project of the microcontainer. What was the actual goal, how it's structured, what's the architecture, and I'll show 2 demos. And then we're going to move on to the current OSGI work, and we have 3 different flavors that we want to support. We call it embedded in the application server. The second one is runtime, and the third one is a facade on top of the MC. And we're going to just mention the current work on the OSGI enterprise group. It's the Blueprint service, and we have a whole new testing environment. We call it Husky. We're going to do another demo as well of the current OSGI stuff. Okay, the goal of the class loading project was able to support and richer class loading models. For example, OSGI or the new JSR 294, or any other that comes along, or whatever you want to do with your class loading. We want to support pluggable architecture, meaning that we want to abstract the class loader API in order not to code directly code against the class loader, but make a proper abstraction. For example, based on policies like we're going to see later on. By that, we wanted to minimize possible hacks, leaks in our code itself. Meaning, for example, you were able to somehow get the details of the class loader which you weren't supposed to by casting it into the proper class. But the change we did was like I said, it's just minimize it to the extent so that even our own core developers wouldn't be able to do different hacks or leaks. And of course, we wanted to reuse existing solutions. That's the VFS part of the MC, and to tie class loading dependencies directly into the existing MC state machine. The class loading project is split into 3 different modules. The first one is actually called class loader, which holds the base class loader implementation. It's done in such a way that most of the details are hidden behind package modifiers. Like I said, so that you're not actually able to exploit some of the functionality of the new class loader. Everything is the class loader itself is policy-based. We have an example of policy, how the policy interface actually is an abstract class looks like. You just express some of the just small, simple details of how your resources should be looked up, or are they cacheable, are they blacklistable, what do you export or what do you import? For example, that's the example of the class loader policy. How it's done, you have a system. There's a class loading system which knows how to create class loading domains, and class loading domains know how to create class loaders based on policies. And of course, a policy plus its policy delegates construct a class loading peer model. Then we move on to the second module. It's called class loading. The whole class loading itself, and like most of the JBoss AS, it's metadata-driven approach, meaning you have a class loading metadata which drives the whole class loading imports and export, the whole requirements. It's tightly integrated with MC state machine, so we have proper class loader or class dependencies. We abstracted in such a way that basically what we have is not just imports and exports, we call them capabilities and requirements, meaning that way we can abstract and move to different class loading models. For us to change to the new JSR 294, it's probably going to be a lot easier than for everybody else, because we already took into account the abstraction based on the, like I said, capabilities and requirements. And what they actually come into, they are turned into dependency items, which are part of the MC state machine. Actually, the whole restrictions are held in a single class, single entry. It's the module class, which is part of your deployment unit. And the thing is, you don't code directly against the class loader, which the class loader itself in JDK doesn't have rich capabilities of looking up for resources and so on. But if you code against our module class, you get all the rich visitor at our API, already knowing all the restrictions. For example, what you filter, what you export, what you import, and so on. So if you actually want to do something against our class loading architecture, you do it against the module class. And then the third module inside the class loading project is class loading VFS. It's basically just a VFS implementation of the policy and of the module. There are two different demos that we're going to show. One is how you actually define your class loading dependencies, class loading restrictions. It's through the class loading metadata, and one of the ways to actually get a class loading meta is to describe it in your JBoss class loading XML.
So basically what we're going to demonstrate is that we have 3 different deployments. Two are MC service and bean deployments that contain MC POJOs. The other one is basically just the equivalent of an OSJ bundle that's just going to supply a class that's referenced by one of the other bundles. And so the 3 different JBoss configuration files that define what those bundles or modules in our nomenclature exporter are shown here. There's a foo.jar that defines that it exports or JBoss Acme Foo. It has requirements on the Acme LS package being version 1 to 2 inclusive. It also has a requirement for an Acme Scott package from version 3 to 4. There is a acme.jar file that includes both the Acme LS and Acme Scott packages with different versions, version 1 on the LS, version 3 on Scott. And actually it does include this third package as in its contents, this org JBoss Acme print, but we're not explicitly exporting it, so it's not going to be visible from the start. That's actually going to be yet another bundle that declares itself as a module. So here we actually are saying that we need to import a module print, right? And that's actually going to have this org JBoss Acme print class in it. The last one is that print jar, which is basically a library that exports the org JBoss Acme print class package and also declares that it is what we call a print module. So it's basically a higher level notion of imports and exports instead of having to necessarily go through all the packages that you're dealing with. The classes that are going to be in the various beans include this foobar service. So basically that's, again, in that package, org JBoss Foo. It's a service that does dependency injection of an LS service and Scott service, okay, based on these interfaces. The LS service is a simple POJO that does have a reference to the pretty print service, which is going to be in the print.jar and print module. We're actually going to print out the code source to show that where we imported that that pretty print class is actually going to be coming from the third-party print.jar, the module that declared itself as the print module, rather than the print.class is actually going to be in the acme.jar. So if you look at the acme.jar, there is a pretty print class in there that should typically satisfy this binding, but because of the way we've configured our class loaders, it's not going to be exported from this. It's going to be imported from that third-party jar.